So you have no doubtedly, been talking about points and lines lots. We are very specific in geometry what we mean when we say line, okay? I know in normal conversation, if I say, okay, go ahead, draw me a line, you're probably going to do something like this, right? So technically speaking, in geometry, that's not a line anymore. That's actually what we call a line segment. So we're going to get very specific today and name these three things and talk about what they are and how to name them. And we'll go from there, okay? So we'll start with a point. Points are pretty easy. It's simply a location in space. And I know when I hear the word space, I'm always thinking outer space. It doesn't have to be outer, it can be outer space, right? But it can be literally anywhere in our physical space. So a point could literally just be right there. To name a point, we just use a single capital letter. So they're super easy. So maybe I'll call that point B. So we name with a single capital letter. All right, they're nice and easy. Now, line is, we're going to define it a little bit more specifically than what we're used to, because like I said, if I just tell you draw a line, we're used to just doing that. And that's not really what we mean in geometry. So a line is going to be a set of infinite points. So the key to a line is that it never ends because it's infinite, right? A set of infinite points strung together in one dimension. So this is fancy language for this. This line, okay, let's break this down. You'll notice that I have arrows on both ends. That indicates that this is going on forever. All right, so that takes care of the infinite bit. So really what a line is, it's just a whole bunch of these single points that are all just right next to each other. So they create this string of points, and all together they create what we refer to as a line. Okay, so I could highlight just some specific points on this line. So here's A, maybe point B is over here, maybe point C is over here. So you just have an infinite number of points, you put them all together, and it creates a line. Okay, so a few things to talk about with lines. They are going to never end in either direction, so that's key. And now let's talk about naming them. And there's actually two different ways to name a line. It's up to you which one you use, but you need to be familiar with them both, because if I name a line, you need to know which one I'm talking about. All right, so to name a line, so method one, and this is your most common one, you're going to see this quite a bit. You can use any 2 points on the line. PTS, by the way, is just the abbreviation for points. So I'll just add that in there because you'll see me do that a lot. Points. PTS. What else is nice about naming them is that the order doesn't matter either. So I can say AB or I can say BA. Doesn't matter. Any 2 points in any order. You know, I'll even add that. Use any 2 points on the line in any order. So if I'm going to name that line above, I could write it out a few different ways. I could say line AB, like that. I could say line BA. I could use the C if I wanted, line BC. You're not going to use more than two, though. So you're not going to call this line ABC. You're only going to pick 2 points. That's all you need. You could also use the symbol for line if you don't want to write out the word. So the symbol looks like this. You literally just draw a line and then you put the letters underneath. So any of those would be acceptable also. Okay, everybody all right so far? Okay, so the next way to name a line, and you don't always get this option, you really only get this option if it's given to you in the diagram, but let's go ahead and write it out and then I will show you. So method 2 says that you can use a single lowercase cursive letter. Now, don't get too hung up on the cursive, not cursive, because I don't even know if you guys learn cursive anymore, right? So a single lowercase cursive letter, and I'll just add off to the side. So what you might see in a diagram, if I just shimmy back up here a little bit, you know what, I'm just going to redraw it down here. That's fine. So I have my line. So even if you have some points on there, what you will occasionally see is that we will put a lowercase letter like over here usually. And because we're not that fancy, we usually start with L for line, but it could be any letter. So typically you'll just see some lowercase cursive letter, L, M, N. That's usually where we start, but it literally could be anything. All right, so now I have another way to name this line. Besides using the points on the line, I could call this line L. Now here's this tiny tidbit is a little bit confusing. L is not a point on this line. See how I didn't put a dot above it like I did for C? B has a dot, A has a dot. Those are all points on the line. L is not a point on this line. That's just a way for me to name the line. It's not a point at all, okay? So if I asked you if point L is on this line, you would say there isn't even a point L in this diagram. I see line L, but there's no point L. It's a little weird to get used to, but once you do, it makes more sense. Okay, one other thing that's weird is that we never use this notation if we're just using a single letter. So in other words, you're never going to see it written like this. No, you'll never see that. If you do, call me up and tell me because I've never seen it. Okay, so the only other thing that I want to mention about lines before we move on to planes is it's a little bit of a vocab word, collinear. Collinear. Does anybody want to take a guess what that word means? Try and take it apart and see if you can. So I'm going to tell you, I'm going to ask you if points are collinear or not. Anybody want to take a guess what they think collinear would be?
Isn't it something to do with straight lines?
basically, so collinear, right? Linear, you see the word line in there. So this definitely has to do with lines. And then this prefix co. So think about like your co-workers are, other people at your job, right? So collinear, they're all going to be points on the same line. That's what collinear means. So let's jot that down. Points that are on the same line. So let me draw you a picture and I'll ask you some questions. And I want you to pay attention because I'm going to ask you a trick question in here too. All right, let me put some points on here. Let's have A, B, C. Let's put a point D right there. All right, you see these lines? So I'm going to ask you some questions. You ready? Are points A and B collinear? Feel free to unmute yourself and just shout it out. Send it to me in the chat. So the question was, are points A and B collinear? This is the easiest one.
Yes.
Yes. You can also give me, you know what, I'll get you in gallery view over here. So if you want to give me thumbs up, thumbs down, that'll work too. Hey, why are there some of you I can't see? You're all supposed to be on here. What? The only people that I don't have to, if you are physically in class, I don't need, obviously, because I can see you on the classroom one, but everybody at home, I should be able to see your lovely faces. And I can't. You will always see some squares that are me because I log in with like 10 devices. So obviously there's one, I only ever have one camera going. You don't need like 6 angles of Mrs. Savia, right? So you're going to see the other squares that are me are just my other devices, but I should see all of you. Alrighty, so back to my question. My question was, are points A and B collinear? And most of you are saying yes, and you are absolutely right. They are certainly on the same line. All right, let's step it up a notch. Are points D, B, and C, all 3 of them, are they collinear? Points D, B, and C. Yes, they are all on the same line. How about points A, B, and C? Are A, B, and C collinear? No, they are not. In fact, we do have a word for that. We can just say non-collinear. Non-collinear would be points not on the same line. Right? Okay, now here's the trick question. Are you ready? Are you ready? Are points A and C collinear or non-collinear? What would you say? I really need everyone's attention here because this is super weird to get used to. All right, is everybody looking at the diagram and you're paying attention to me? Because I am going to ask you questions on this and I want to make sure that you get them right in the future. At first guess, most kids say no, A and C are not on the same line. And I could totally see why you would say that, right? Because it appears as though A is on this line and C is on this line. Here's the thing about collinear and non-collinear. It doesn't matter if the line is drawn or not. So even if I don't have a line drawn that connects A and C, the question is really, could you draw a line that connects A and C? So if you can draw a line that connects A and C, then they are collinear. That's interesting. So let's make a big note about this. And I don't really have a ton of room here. So I'm gonna flip my notebook and I'm gonna sort of redraw this image because this is a big deal. So I had something like this going on. I think I had A, B, C, and then point D was here. So collinear, I'm just going to make a little list here. Collinear, non-collinear. So we had said collinear A and B were. We said D, B, and C were. Non-collinear, we said A, B, and C. And now I'm claiming that A and C are. So I'm going to add a big star here and explain this. If a line can be drawn connecting the points, they are collinear. And when I say line, I mean one single straight line. You can't be making zigzags or curves. One straight line. If one straight line will connect the 2 points, then they are collinear. Let me ask you, are points A and D collinear? Are A and D collinear or non-collinear? What are we saying? Send me answers in the chat. Give me thumbs up, thumbs down. I don't care how you relay your answer to me, but I want to see your answer. A and D. Yes. There is not a line drawn in the diagram that connects A and D, but I could draw a line that connects them. So, think about this. Are there 2 points that you couldn't connect with a straight line? And I want you to think about straight lines like laser beams, right? So they can go through walls, they could, or like a, you know, a lightsaber or something. Imagine that it could just go right through the earth if it wanted to. So if I had a point here and then I had someone else in China with a point, couldn't there be a laser beam that connects those 2 points? Right? If you imagine, it goes right through the earth. Guess what? Any 2 points, anywhere in the galaxy or in other galaxies, it doesn't matter, they are always collinear because you can always connect any 2 points with a straight line. If you're ignoring walls and the core of the earth, if you can, right? Any 2 points are collinear. So you actually don't even need a diagram. If I say, hey guys, are points X and Y collinear? The answer is automatically yes. If I'm only talking about 2 points, they are always going to be collinear. Now, when I ask you about 3 points, maybe they are, maybe they aren't. So we had an example. Here are 3 points that were, and here's 3 points that aren't. So that's going to be a different story. But big star, big takeaway from today, any 2 points are collinear. You literally don't even need to look at a diagram. I'll say any set of 2 points will always be collinear. You don't even need to think about it. So when I make those popsicle, I don't even know if I told you about the popsicle sticks. I take everybody's name and I put it on a popsicle stick. I haven't done it yet, but I will soon. And then I just call on you at random by picking your popsicle stick. Super fun. So I will eventually have them and I will just be calling on you. So if I pick your name and I say, hey, are these 2 points collinear? I just gave you a gift because the answer is always yes. Always. If I'm talking about 2 points. If I'm talking about 3 points, now you need a diagram because maybe it is, maybe it isn't. That's so cool. All right. So There's everything that I need to tell you about lines. Now we're ready to talk about planes. You guys ready? I'm ready. Let's talk planes. So planes, we are spelling it like planes in the sky, but it doesn't mean the same thing. So not planes like prairies and plains, like the, I don't know, amber. Oh, it's amber waves of grain. You know what I mean. Planes like on the farm. I don't know. We're talking about these planes. But what do they mean in geometry? So in geometry, it's going to be a flat surface with no thickness that continues forever. That's weird. That continues forever in 2 dimensions. Oh, I'm sorry. So we started with the point. Points have no dimensions. They're just a spot. Then you have a line. That's 1 dimension going side to side forever and ever. Now we're going to expand that 1 more dimension. Planes now not only go side to side, but they go up and down. They spread out forever. And you are very familiar with a plane, whether you realize it or not, the coordinate plane, right? Every time you plot 2, 3, you're on the coordinate plane. The coordinate plane never ends, right? I mean, it might end on your paper because we can't draw it forever, but you could just, like on a calculator, you could, or a computer, you could just tell it to move your window to somewhere else because the coordinate plane never ends. You could keep zooming out forever if you wanted. So that's our favorite one. Now, how in the world are you supposed to draw this, right? How am I supposed to draw this thing that goes on forever and never ends on a piece of paper? So we have we sort of have a way to do that. So to draw what we have accepted represents a plane is you really just kind of draw yourself a parallelogram. So that's how we draw what we are referring to as a plane on paper. Anything that I want to show you that's in the plane, for the most part, I just stick it inside the parallelogram. If I want to show you something that's outside the plane, I just stick it outside the parallelogram. For the most part. Okay, so if I wanted to show you points A, B, and C in the plane, I would just draw them like that. Okay, I'll stick another point over here. Let's have this be point X. Another way that's a little less common, but you might see a plane drawn this way. I never draw it this way because it takes way too long. But I just want you to have an example of it. Sometimes people just do it with lines like this. And this is, I do like this because it helps you remind you that, hey, this never ends. It just keeps going out forever in all these directions, but it takes forever to draw it, right? So that's the same idea. Okay, so we need to talk about naming planes. How do we do this? So this is a little bit more complicated, but it's not too bad. Again, we have 2 methods. I don't know why we love having multiple ways, but we do. So I needed to be familiar with both. So let me go through each one. So let's go ahead and start with method 1, which is probably your more tried and true method, I guess. Method 1. You are going to use any 3 non-collinear points, and it does have to be non-collinear, in any order. All right, so here's the deal, non-collinear. So it looks like points A, B, and C are just going to fall right in the same line as each other. So points A, B, and C, they are collinear. I could not name this plane ABC. Why not? Those are 3 points in the plane, but they're not I need them to be non-collinear. Let me try and show you why. Let me use my super cool Post-it note here. So imagine that my Post-it note here was another plane. So I have one plane here on the paper, but imagine I had another one right here. Wouldn't this yellow plane also have points A, B, and C in it if it was set up just like this? Sorry, my hand's moving an awful lot. There we go. See that? So there's a second plane, and it's kind of like coming up off my paper. And it also contains points A, B, and C. So if I name the plane A, B, and C, but there's more than one plane that has points A, B, and C in it, how am I supposed to know what plane I'm talking about? I wouldn't. So that's why you are not allowed to use collinear points to name a plane. They have to be non-collinear. So in this example, I could certainly call this plane BAX, for example. Those 3 points are not on the same line. I couldn't put them on the same line even if I tried, right? Because a line is one single straight line, not zigzagged or curved. So BAX would be just fine. And there is only one plane that contains those 3 points. If I tried to do the same thing with my Post-it note, and I tried to contain points B, A, and X, I can't without literally just having the exact same plane. So let's go ahead and jot that down. So we're going to call this plane ABX. And again, order doesn't matter. And you could have used point C if you wanted, CXA. That's fine. It doesn't matter what 3 points you use. They just can't be A, B, and C because those are the 3 that are on the same line. So I'll add a few more choices. You could have done AXC. You could have done BXC. There's lots of choices, okay? You can choose any one of them. It really doesn't matter, and the order doesn't matter of the letters, as long as they are non-collinear. All right, and then method 2. I like it because it's simpler, but you don't always get this option. So method 2, I'm going to zoom down a little bit, and then I'll put it back in my diagram. Use a single capital uppercase. Oh, wait, that's what capital means, silly goose. Use a single capital, cursive is the word that I meant. Cursive letter in the corner. I don't know why it's always in the corner, but it is. So sometimes this is helpful when, especially if we have like a whole bunch of planes in a diagram. So just an easier way to refer to one plane at a time. I'm going to zoom back up to my my diagram here so we can see. So what they're going to do is they're going to put in the corner, they'll put sort of, I'll try and make a cursive capital P, but it's never going to. Every time I do this, I feel like Billy Madison when he's trying to do the cursive Z's. Oh my gosh. Have you guys even seen this movie? No, right? Or have you? Billy Madison? Oh, gosh. Mr. Orlick.
Yes.
Have you? Oh, you've seen it?
What was it?
Billy Madison?
Oh, yeah, of course.
Okay, good. Every year, like I just get so much older than these kids and they get less and less of what I'm talking about.
I know.
Oh, it's devastating. Like they don't know. They don't know. I'm talking about when he tries to write Buzz with the cursive Z.
Yeah, and he scribbles them.
Oh, I can't write in cursive anymore. That's so hard.
I can't either.
All right. So that's, and similarly with the line, there is no point P here. See how it doesn't have a dot next to it? There's no point P in the plane. It's just the name of the plane. All right. So that is, I know it's a little weird, hard to get used to. So my other way, now I can just call it plane. And then I try and make that cursive P again, but of course it always comes out funny. Okay. So far, is everybody all right? We're okay-ish? Because the only thing I have left to talk about real quick are just the ray and line segment, and then we're done. But I think that's old news for you guys, so that should go pretty fast. I do have to turn the page, so grab what you need before we turn. Okay. Oh, and you know what? We should throw on here too that just like we had collinear and non-collinear, you also can have coplanar and non-coplanar. So, and it means exactly what you think. So coplanar is just going to refer to points, or you could have lines now, points or lines on the same plane. And then obviously non-collinear, points or lines not on the same plane. Non-coplanar, sorry. Non-coplanar. We'll just say not on the same plane. Okay, so don't get thrown off by those words. They're pretty easy if you kind of just break them apart. Coplanar, on the same plane. Non-coplanar, not. All right, so next up is our friend Ray. I have been waiting years and years to have a student named Ray in my geometry course, and it never happens. Ray. So what is a ray? A ray is basically part of a line. We just cut off one side, kind of, right? So I'm even going to say similar to a line. But has one definite endpoint. And the other end continues forever. So I know this is what I mean with geometry. You're going to hit stuff that you are familiar with, right? I'm pretty certain that you all have learned about rays at some point in your life, but maybe you haven't learned about planes. I don't know. So there'll be some things that's old, some things that's new. And the problem is, yay, I have a ray now. Was it? I'll go with it. That's as close as I'm ever going to get, I feel like. All right. So here's the thing with naming rays. You don't get as much liberty as with everything else, right? You don't get to do it in exactly any order you want. You have to start with the endpoint. That's the biggest deal. The other point, you get to name whichever one you want, but the endpoint has to be first. Okay, so that's the big deal here. Oh, sorry. I'm trying to get this lined up. There we go. All right, so to name, you must, this is crucial, must name the endpoint first. Then choose any other point on the ray. Okay, so this ray that I have drawn right here, I only have two ways that I could choose to name this. I have to start with A because that's the end point. So you can name it ray AB or ray AC. That's up to you. And we do have a symbol for it. So if you did ray AB, instead, you could just do it like this. You draw a one-sided arrow, and you make sure that you put the endpoint first, and then the B. All right. So your other option was ray, what did I say? AC. So again, symbolically, you could have done like that. So either of those is fine, but it has to start with A. Even if, and sometimes kids get confused by this, even if in your diagram the ray is going this way, So if this was, I don't know, let's say that's X and that's Y, you still have to name this ray XY. Because it doesn't matter. We don't really care about the direction. I just care that you're starting at the endpoint and then you name another letter along the ray. So this, written symbolically, it's still, the arrow always points to the right when I'm just writing it like as an answer or something. And I have to put X first and then I put Y. So we really don't care how it looks in the diagram. When you go to name it, arrow always points to the right and point first. Okay, and we are almost done. Last thing is line segment, and they are super easy. Line segment is kind of, am I going too fast? I'm sorry. I'm going to try and leave that up if you still need it. I'm just trying to make sure that I get through everything before time is up. Line segment. This is really just a portion of a line. And this is what we get lazy and we refer to line segments as lines all the time. We do this constantly. So like in the beginning of class when I said, hey, draw a line, you literally drew a line segment, right? Because that's what our brains just interpret as lines. But we need to be really specific here. So what you're actually drawing when you draw like I just did here, this thing that I drew underneath to underline, underline, right? That's really a line segment. So I really shouldn't be calling it a line. So anyway, portion of a line with two definite endpoints. Naming is super easy because I'm just going to use the two endpoints in any order. So here's an example of one. So here's point L, here's point M. To name, oops. Just use two endpoints in any order. Oh, and with a symbol, you can just put a bar on top. So this will be segment LM or segment ML. Up to you, doesn't matter. They are the same. And that's it. Okay, guys, so your homework this evening is actually on Delta Math. So if you are familiar with Delta Math, just hop on over there. It should already be live for you. Okay, if you are not familiar with Delta Math and you're like, I don't know, I never used it before. Hopefully we all have our accounts set up. If you don't, we'll walk through that. If you need to, we don't have a ton of time, but just reach out to me through email and I'll help you set it up. It doesn't take very long. It should be pretty quick. And everything you need is on that rainbow sheet that I sent you. So you should be able to do it on your own if you need to. All right, so let me stop this share. So if you are comfortable, hop on over to Delta. If you see it and you're good to go, then that's fine. If you are confused and you're like, I don't even know what I'm doing. So I'm going to walk you through it. So first, you start off by going to deltamath.com. So let me share the screen. Yeah, is that what I want? Let's see if that works. So yeah, deltamath.com. DELTAMATH.com. So you should have already set up your account yesterday. So then just go ahead and click sign in once you enter in your info, obviously. If you have not yet created an account, we'll have to do that in a few minutes. But everybody else, you should just be able to log in. Now yours is probably going to look like, oh, here's Anthony. What? Anthony, hi. I've already finished the lesson. Oh, let me stop the video. I don't think we need it.